Hello. In this video we are looking at rates of change. So we're going to go back and have a look at the chain rule again. Questions on this particular topic tend to be about shapes, maybe volumes and surface areas and things like that. So what you can expect to see, a question will give you two pieces of information. One will be a rate of change and one will be a value for a variable, and you'll be asked for a different rate of change. So as I say, we're going to use the chain rule. So we're going to have to set one of those ourselves. And then using our knowledge of shapes, we're going to find a new differential and solve. So here's example one with a two-part chain. We are told that the sides of a cube are increasing at a rate of 11 meters per second. And we are asked how fast is the surface area increasing when the surface area of the cube is 150 meters squared. So going back to the list of information at the top right, as it says, the question will give you two pieces of information. Well, we've been told that the sides of the cube are increasing at a rate of 11 meters per second, and we can write that as dl by dt equals 11 meters per second, where L is the side of the cube, the length of the side of the cube, and t is time. And we're also told the value of a variable. We're told that the surface area is 150 meters squared. It says cubed there, but we mean squared. And then we've also got a question. The question says, what is dA by dt? Well, it actually says how fast is the surface area increasing, but that's asking us what is dA by dt. So we need to set up the chain rule. This is the important bit. So we want to find dA by dt, and as we know, we can write it using the chain rule as fraction multiplication. So for example, dA by dl times dl by dt. We've already been told what dl by dt is. It's 11, so that makes sense that we need to include that. And that means that we would need dA by dl to complete the chain rule. So in terms of knowledge of shapes, if we want to find dA by dl, then that means we need to know what the surface area is so that we can differentiate it. And we want it in terms of L. And for a cube, the surface area would be 6L squared. Each face on the cube is L squared, and there are 6 of them. So if A equals 6L squared, that means that dA by dl will be 12L. So that means that dA by dt is going to be 12L times 11, which is the same, of course, as 132L if we wish. Now, we've also been told that A equals 150. So on that basis, we want to work out what L is. So 6L squared is equal to 150. And divided by 6 and square rooting, that means L equals 5. So each of the sides of the cube is 5 meters long. So dA by dt, it is 12L times 11, or 132L. Replacing the L with 5 gives us an answer of 660. And the units are meters squared per second, because we're talking about the rate of change of area. And the area was given, or should have been given in meters squared, and the time unit is the per second. And let's do the same thing again, but this time with a three-part chain. We're told that the surface area of a spherical balloon is expanding at 3.5 centimeters squared per second. So we're talking about spheres, so we need to know things like the volume of a sphere and the surface area of a sphere. And then we've been asked to find the rate of expansion of the volume when the surface area of the balloon is 576 pi centimeters squared. So again, we've been told a rate of change. In this case, it's dA by dt, because the surface area is expanding. So 3.5 centimeters squared per second. And again, we've got a variable. In this case, it's the area again, 576 pi centimeters squared. And the question this time wants us to find dV by dt, the rate of expansion of the volume. So we've got dA by dt, we want dV by dt, but of course in terms of shapes, in terms of spheres, we know the volume and the surface area in terms of R. So it makes sense to have a three-part chain with a dV by dr, a dA by dr, and a dA by dt. But in order to make that work, we want the dA by dt as it is, we want the dV by dt on the left as the subject, the t's are on the bottom. But when we do our dA by dr, we actually want the r to be at the top and the a to be at the bottom. We want the dA's to cancel out and we want the dr's to cancel out. So in order to set it up properly, we need to have dA by dr but reciprocated. And then in terms of knowledge of shapes, we know for a sphere that the volume is 4/3 pi r cubed and the surface area is 4 pi r squared, both of which we can differentiate. So we've got dv by dt equals dv by dr. If we differentiate 4/3 pi r cubed with respect to r, we get 4 pi r squared, which of course is the same as the formula for the surface area of the strip. If we differentiate 4 pi r squared with respect to r, we get 8 pi r, but again we've got to reciprocate it because we're looking for dr by dA rather than dA by dr, and we know that dA by dt is 3.5. It was given in the question. If we multiply 4 pi r squared by 1 over 8 pi r by 3.5, that simplifies to 7r over 4. So we have an expression for dv by dt in terms of r. We do need to work out what r is. We've been told the surface area is 576 pi. And again, we know the formula for the surface area is 4 pi r squared. So if we put that equal to 576 pi, the pi's cancel, we divide by 4, that gives us r squared as 144. And then we square root it and we get that the radius is 12. Hence dv by dt is 7 times 12 over 4, which is 21, and the units are centimeters cubed per second.